Hey y'all, today we are going to look at comparing graphs and slopes. So we're going to start with this first question. It says consider the following equation. Look at that equation and think about what form is that equation in. And hopefully you said that that equation is in standard form. Remember, standard form is ax plus by equals c, where x and y are together on one side, and that's what's happening in that equation. Write the equation in slope-intercept form. What is slope-intercept form? Hopefully you answered that. Slope-intercept form is y equals mx plus b. Think about what are the two most important things when it's in slope-intercept form. They are your m, which is your slope, and your b, which is your y-intercept. Okay, so we're going to take this equation I have right here, and we're going to put it into slope-intercept form. So my goal is to get y by itself. So I cannot touch that positive 4y until I get rid of that 3x. How do I bring 3x to the other side? Subtract 3x. So 4y equals, remember, when you're rewriting this, you go bottom to top. So it's a negative 3x plus 12. In order to finish getting y by itself, I divide every single thing by 4. And reduce if you can. So 4 divided by 4 is 1. 1 times y is y. Negative 3/4. I can't reduce that, so leave it. 12 divided by 4 is plus 3. So you've successfully changed it from standard form to slope-intercept form. Now I want to graph it. Remember, in order to graph, you have to know two things. The two things we just talked about over here, the slope and the y-intercept. So what is our slope? Very good, it's negative 3/4. What is our b value, our y-intercept? And that would be positive 3. So in order to graph, which it says in part A, where do I start? Very good, start at the y-intercept. Put a dot there. And then do your slope, your rise over run. So the negative 3 in the rise tells me to go down 3. The positive 4 in the run tells me to go right 4. And it doesn't look like I can do it again because I'd be off the graph. Can I go backwards? Up 3, left 4. I could add one more right there. So I was able to make 3 dots. Go ahead and extend your line, put arrows at the end. All right, identify the y-intercept. We just did that, and the y-intercept is 3. Identify the x-intercept. So let's go look. Where does this graph cross the x-axis? And it actually crossed the x-axis right here. What is that ordered pair? That would be 4, 0. I probably should correctly write the y-intercept, but yes, the y-intercept is 3, but what's the ordered pair there? That would be 0, 3. Remember, that's your y-intercept. The ordered pair is 0, 3. Identify the slope. We've already done that. So m equals negative 3 divided by 4. Now think about this. When you look at this graph from left to right, it is going down, so it is decreasing. Your domain and your range. Your domain is your x values, your range is your y values. You're going to get all real for all of these. Whenever it makes a line like that, it's going to be all real numbers. I could always check myself, and I could go ahead and put in my standard form equation and my slope-intercept form equation into my calculator, and I could make sure that they actually are the same exact thing. So if I went ahead and plugged them in, so standard form, 3x plus 4y equals 12. Now go down to the next one and put the slope-intercept form one in. Y equals negative 3 divided by 4, use your over arrow, add the x, plus 3. And look at that, they are the same exact thing. Remember, if you do this, you can also go and get a table for the one that's in slope-intercept form. So you could do a bunch of different things here, but that's a way you can check yourself to make sure you know you're correct. All right, consider the following equation. So I have equation A and I have equation B. What form are both of those equations in? Very good. Hopefully you answered correctly. They are both in standard form. Remember, standard form is ax plus by equals c. Okay? It says graph the two equations using Desmos. So let's go over to our Desmos and let's plug in each one. I'll plug in a first. So 2x plus 3y equals 12. And then 2x plus 3y equals 6. So really it looks to me like the only difference is the equals 12 and the equals 6 there. Okay? All right, so if you notice my graph, before we look at what's alike and what's different, if you notice my graph here, my graph has, what is it counting by? So this right here is 0, 2. It looks to me like it went up 2. So 2, 4, 6, 8, 10. So it's counting by 2s. You want to be careful as to what interval it's counting by. If I zoom out a little, or actually I want to zoom in. If I zoom in a little, it should make it then count by 1. So I go from 0 to 1, then to 2. Okay, so you probably always want your graph to be counting by 1 so you don't make any silly mistakes. So what's alike, what's different? What's alike? Well, if you notice, both of them are decreasing. So if they're both decreasing, what kind of slopes do they both have? They both have a negative slope. Well, let's dive further and actually look at their slopes. Okay? So if I look at my 2 points for my red graph, I'm going to start from the top point and go to the lower one. So rise over run. I rise down, which would be negative 2, and right, which would be positive 1, 2, 3. So for that top one, my slope is negative 2 over 3. Now let's look at the bottom one. Or sorry, that was the bottom one, the red one. Now let's look at the top one. So if I click on the top one, it gives me 2 points. All right, so I got 2 points here and here. So this is at 4. If I go from this point to the other one, I go down 1, 2, 3 to give me negative 4. And I go right 1, 2, 3, 4, 5, 6. So the slope of the second one was negative 4 over 6. And guess what that reduces to? That reduces to negative 2/3. So notice, yes, it's decreasing. Yes, the slopes are negative. And the slopes are actually the same. So they have the same exact slope. These two lines are parallel, and parallel lines are going to give you the same exact slope. So that's kind of a correlation there of how they're alike. What is different? So look at that and see, what do you think is different here? And I would think where they cross the y-axis. This y-intercept was 2, this y-intercept was 4. So their y-intercepts are different. So their slopes are the same. They both have a negative 2/3 slope, but their y-intercept is a little different. What's the x-intercept for line A? So line A is my black one, my top one. And as long as I'm clicked on this, the x-intercept, I can hover over it, is 6, 0. What's the x-intercept for line B? Well, I'm going to click on line B. That's the second one, the red one. And as long as I'm on it, it gives me my 2 dots. The x-intercept would be 3, 0. Are the lines increasing or decreasing? We talked about that. They are decreasing. Line B was translated what? Line B is my red line. Translated means it's shifted. It's shifted up or down or left or right. So they're asking me basically, how did I get from the black line to the red line? I translated it down 1, 2 units. So it's translated down 2 units. All right, let's move right along to the very next question. So considering the following equations, so I got equation A and equation B. And again, what form are both of those in? They are both in standard form. Okay, so it says graph them both using Desmos. So let's go to our Desmos. Let's put them in. All right, so 4x minus 2y equals negative 6. and then 3x plus y equals 3. All right, so I got my green line and my blue line. Which of the following statements is true? Okay, the slope of both lines are the same and the y-intercepts are different. Well, let's look at this. The blue line increases from left to right, so that would be a positive slope, and the green line decreases. So are their slopes the same? No way. That question also said the y-intercepts are different. Well, it looks to me like they both cross the y-axis at 0, 3. So that's not true. The slopes of both lines are different and the y-intercepts are the same? Looks like that might be. Let's check everything else. The slopes and the y-intercepts of both are the same. Well, we know that's not true because we said their slopes are different. The slopes and the y-intercepts of both lines are different. Well, we know that's not true because we know the y-intercepts are the same. So option B is our best option. All right, which linear relationship has the greatest slope? That means each one of these options is a linear relationship, meaning it forms a line. Which one has the greatest slope, the steepest line? So we're going to check each one in Desmos. I'm going to show you how to check, even with an ordered pair, a table, all that good stuff. First, we should easily be able to find the slope of D. So let's make 2 points on D, the graph, and let's find the slope there first. Hopefully you realize it increases, so I know it should be a positive slope. So I'm going to rise up 1, and I'm going to run right 2. So that would be positive 1 over 2. So the slope there is 1/2. The rest of them I can check on Desmos. So let's go to Desmos, clear out what I have, and I'm going to put those points in. All right, so let's see if I could do it this way. All right, so I'm putting each one in. Instead of the brackets, I don't have brackets on here, so I did just a set of parentheses, then another set of parentheses. I'm gonna put each, whoops. All right, 5, comma, 3, close parenthesis, comma, open parenthesis, 8, comma, 2, close parenthesis, comma, open parenthesis, 11, comma, 1, close parenthesis, and close it again for the end. And let's see if that graphs, it doesn't look like that's going to graph my points. So you know what? I actually do need the squiggly brackets. So on your device, the squiggly brackets are next to the P. So if you use the shift button and put that, and then I'm going to go to the end and fix the ending one. And if I use the shift button and put the other one, I should be able to get my points there. Oh, you know what? Silly me. I got to put it in a table. I'm not even thinking right now. Remember, using Desmos is new for all of us. So I got to put a table in, and I can put a table in for a set of ordered pairs. If I hit a plus sign and I click table, I can type all my X's in, 2, 5, 8, 11, and then the Y's that go with them, 4, 3, 2, and 1. Sorry about that, not even thinking. So I'm going to minimize this so I can kind of see. I can see all my dots there. So I want to figure out what the slope is. And I'm actually going to go back to the home. So it's counting by 2s. I want it to count by 1s. Okay, so if I zoom out a little, it's now counting by 1s. That goes up 1, 2, 3, 4, 5. Remember, I only need 2 points. I mean, I can clearly tell that it's decreasing. I only need 2 points. So if I'm going to start at this top point, and I'm going to go down to the other one. Okay, so I need to rise down 1, and I need to run to the right 1, 2, 3. So your slope for this one would be -1/3. All right, so my slope here is -1/3 for A. We got our slope for D already, so let me put it down here so I can compare. And then I got B and C. So again, let's put B into our calculator. That equation's in standard form. So 8x minus 4y equals 12. All right, let's see. I'm going to go... All right, I got 2 points there. You notice how I didn't fully see this x-intercept, but I plugged it in there and it's 1.5 and it tells you. So the y-intercept is -3, the x-intercept is 1.5. So I'm going to use my rise over run with those 2 points to find it. So if I start at the bottom, I have to rise up +1, +2, +3. So +3 for my rise. And then for my run, I have to go right, which is +1, +1.5. And if I check myself really quick, and I'm just going to do it right here, 3 divided by 1.5 equals 2. So the slope of this one is 2. All right, next one I'm going to put in is C. I'm going to put that table in and see what my slope is. So go to the plus sign, go to table, I can add in all my x's. Add in all my y's. All right, so clearly that decreases. Let's pick 1 point, go from 1 point to the next. And my graph is counting by ones, which is good. If it's not counting by ones, you got to be cautious there. So I'm going to start at the top and go to the next one. So I go down 1, 2, which would be -2, and I go right 1. So my slope, this one is -2/1, which is just -2. Now, keep in mind, these slopes are both 2. One of them is just negative. Would that be, do they both have the greatest slope? Right? Are they both as steep as each other? Technically it would be. So if you go ahead and put, technically they would be as steep as each other. So the greatest slope really would be both of them. Even though this one is negative, your the steepness of your slope is still going to be the same even though one of them is negative. Okay, so just be cautious of that when you're checking the slope. Notice for this one right here, it wasn't as steep. Like if I were to walk up that hill, it's not as steep as if I were to walk up this hill over here on my calculator. That would be a lot steeper. Okay, so the smaller the number, the less steep the slope. The bigger the number, the more steep the slope. All right, the following graph represents the amount that Camilla and Lydia charge for their babysitting services. So here's Lydia's line, here's Camilla's line. So it looks to me like Camilla's is a little bit steeper. Lydia's is not as steep. Now keep in mind, number of hours babysitting is on the x-axis, and what they charge for babysitting is on the y-axis. Going over my numbers here. Okay, so keep that in mind. All right, which of the following statements is true? Select all that apply. So this could be more than one. The rate of change, which remember, rate of change is the same thing as slope. The rate of change of each line represents the amount each girl charges per hour for babysitting. Well, number of hours babysitting. If I look at 1 hour, and I get right there for Lydia, it looks to me like Lydia charges $5 or $6. What about for Camille? If I go up a little more, it looks like Camille's almost at 10, so it's not exactly on it, so we kind of might need to figure that out, but this is correct. The rate of change of your slope represents the amount each girl charges per hour, so that's going to work out. Lydia's rate of change is greater than Camilla's. Well, didn't we just say Camilla's line is steeper? That means her slope is better, is greater than Lydia's, so this is not true. Lydia's rate of change is 7, so I actually have to find the rate of change of each one of these now before I can move on. So Lydia, let's find 2 dots for Lydia. I see one right here at the origin, and then I see another one, looks to me like right up here. Okay, so I'm going to do my rise over run. I'm going to go up first, 5, 10, 15, 20, 25, 30, 35. So Lydia is up 35, and right, that's counting by 1, 1, 2, 3, 4, 5. 35 divided by 5 is 7. That means Lydia charges $7 per hour of babysitting. All right, now let's look at Camilla. Camilla, I can use that, and let's find another dot that lies exactly, and it looks to me like it doesn't come till up there. Okay, so I'm going to go rise up first, positive 5, 10, 15, 20, 25, 30, 35, 40, 45. So Camilla is positive 45 for her rise, and her run is positive 1, 2, 3, 4, 5. And 45 divided by 5 is 9. That means Camilla charges 9 per hour of babysitting. All right, so now that I have enough information, I might be able to go answer these questions. Lydia's rate of change is $7 per hour. Well, I found that to be true. Camilla charges $35 for 5 hours of babysitting. Well, we found out that Camilla charges $9 an hour. 9 times 5 would be 45, so that would not be true. She charges, for 5 hours, she's going to charge a total of $45. Lydia charges $14 for 2 hours. Well, we figured out that Lydia charges $7 per hour. If it's 2 hours, 7 plus 7 is 14, so that is true. So those 3 situations were true statements regarding this graph. All right, we're going to go into identifying linear functions. Now, please keep in mind, I am not going to do all of these with you. There are some that you're going to have to finish on your own, and we'll circle them. And when you go ahead and upload your video today, I will check those ones that you needed to do on your own. Okay? So when I tell you you need to do them on your own, you can stop me right then and there and pause it, and you can do them, or you can wait till the very end and go back and do them yourself, whatever you feel is best for you. I can identify a linear function from a graph. Remember, a linear function means it forms a straight line. All right, so is number 1 linear? Yes, it is linear. Makes a straight line. Is number 2 linear? It is not linear. That is a parabola. It is a smooth curve. Number 3 is a vertical line. Remember, a vertical line is when x equals a number, and that number that x is at is what, positive 3? So would that be linear? Yes, it would. So the first and the third are linear. The middle is not. It's pretty easy to identify. But now let's look at it in a different context. So what if I ask you to identify it from an equation? I'm literally going to put every one of these into my calculator and see if it makes a line. So let's clear what I have here. So x equals 2y plus 4. Does that make a line? It does. So I know this one. Next one, y equals 1 divided by 3, x, whoops, oops. Remember, I got to go over to get the x on the end, minus 4, not minus 1, minus 4, and that makes a line as well. What form is this one in? That one is in slope-intercept form. Hopefully you realize that. The first one isn't in any specific form at all. All right, let's look at that next one. So y equals 1 divided by x. Ooh, does that make a line? No, that certainly does not. So that is not linear. You guys are going to go ahead and check these 3 and write whether it's linear. So I should have wrote linear here, and not linear. Y'all can pause this and go ahead and answer those 3. All right, so now I'm giving you a table and a set of ordered pairs, and I want to know if those are linear. Well, we can put it in our calculator and see. So remember, a table, to put it in, I hit the plus sign and I hit table, and I'll put in all my x values. And then I'll put in all my y values. All right, and I can kind of tell here, I may have to move it around a little, but I can tell there that that makes a straight line. It increases. So would this one be linear? It would be linear. I'm going to jump to number 12 and do number 12 with you. The set of ordered pairs. Remember, the set of ordered pairs, make it a table, just like we did in the first one. So actually, I could have written right over that one. So the y values, -2, 1, or sorry, I'm doing the x values, 0, 1, 2, and now I can put in the y values that correlate to them. All right, and then I can kind of tell already that if I connected that, it looks like it would be like a U. Remember, that's a parabola, that's a smooth curve. So is this one linear? Not linear. All right, y'all are going to do 11 and 13 using your calculator. Pause this video if you need to right now before you move on to the next. All right, let's see what we got here. We got line T. We have triangle ECA, that bigger triangle. We have triangle FDB, are shown in the coordinate grid below. Which of the following statements are true? Select all that apply. All right, the slope of line AC is equal to the slope of line BD. Well, I have no clue what the slope of each one is, so I'm going to go ahead and I'm going to do my rise over run to figure out. So AC, where's line AC? That looks to me like it's right here, this red part. So I'm going to start at the bottom, and be careful, this graph, yes, this graph is counting by 1. You always want to make sure you know that. So I'm going to rise up 1, 2, 3, and I'm going to run right 1, 2, 3, 4, 5, 6. Remember, 3 over 6 reduces to 1/2. Now BD, I'm going to do that in purple. BD, all right, so BD is this line here. That also increases, and so I'm going to start at the bottom and go to the top. I go up 1, +2, and I go right +1, 2, 3, 4. 2/4 reduces to 1/2. So are those slopes equal? They are. The slope of AC is equal to the slope of line T. All right, well, I already know the slope of AC. Let's look for the slope of line T. Now, the slope of line T, that's this big line right here. Remember, I can pick any 2 points. Does it matter what 2 points I pick? It doesn't. I could pick A and C. They're on that line. So if I do the slope, aren't I going to get the same slope I did for AC? I am. So that one works as well. All right, the slope of line T, which we already know is 1/2, is equal to EC divided by AE. That just means the distance of line EC. Well, line EC is 1, 2, 3, 4, 5, 6 units long. So I have 6 units long for EC, and line AE, oh, that's this vertical one right here. I go up 1, 2 is 3 units long, and 3 divided by 6, or sorry, 6 divided by 3 is 2. So are those slopes the same? Is 1/2 the same as 2? It is not, so that one doesn't apply. The next one asks me the slope of line T, which I know is 1/2, is equal to BF divided by FD. So I got to find that. Where is BF? BF is this vertical spot right here, which it looks to me like it's up 1, up 2. So it's 2 units long. Oh, that's FD. And FD looks to me like it's this one right here, and it's 1, 2, 3, 4 units long. So 2 over 4 reduces to 1/2. So is line T the same as BF divided by FD? It is. The y-intercept of line T is 0, 2. Here's line T, this whole thing. The y-intercept crosses right here. Is the y-intercept 0, 2? It certainly is. Line T represents a discrete function. Remember, when we were in our function unit, we learned about discrete and continuous. Discrete was just dots on your graph, not connected. Continuous was a line or a smooth curve. They're all connected. So this is not a discrete graph. This is a continuous graph. All right. So you are going to go ahead and answer all of this question as well. So we've had to do a few together, and you're doing a few on your own. So you're doing this question. Hopefully you already did 11 and 13 when I told you. And then you had to do 7, 8, and 9. So y'all have what, 5, 6 questions? Yes, this last one is a little bit longer, but remember, you're using your Desmos calculator, but first it wants you to rewrite the equation in slope-intercept form. So first you have to do a little bit of work, put that work right there, and then you can use Desmos for the rest. If you have any questions, email me. I appreciate you behaving appropriately while I'm not here, but I will be checking my email even though I'm not here. So if you have any questions, email me, send me a remind message, and I will help you the best way I can. Keep in mind, the next page, the next page said something about linear functions and nonlinear. We're going to work on that on Friday, so you do not have to complete that. You just have to complete what I've told you so far, and then you are going to take pictures of it. So keep in mind, that's 1, 2, 3, 4 pictures of all those notes. Please make sure the pictures are clear. A lot of you are not giving me clear pictures, and I will return that with a 0 as a grade for you to fix. All right, let me know if you have any questions. Good job. Keep working hard.